All right, so we're going to start our polynomials unit. Today is just going to be a review. Let's scoot this out of the way. So polynomials, if we're defining them, there are many terms that are either added or subtracted. And remember, a term is anything that is either a variable with a coefficient, or a constant term that is just a number. Our exponents are all positive, and x is not in the denominator. Those are all super important things to remember. When we're putting a polynomial in standard form, they're going to go in order from biggest exponent to smallest exponent. So here, this example, I see that the highest exponent is 3, so that would go first. The next one would be 2, and then 1, and then just my constant term. Naming polynomials, we saw this in Math 1. Everything is named by the degree and the number of terms. So if you think about it, every polynomial has a first name and a last name. The first name is given by the degree, the last name is given by the number of terms. So looking at our examples down here at the bottom, 6x plus 1, well, my highest degree technically is a 1. So this would be linear. And since there's 2 terms, it would be a binomial. Here, my highest term is a 3, so this would be cubic. And then my highest degree is a 3, and there are 3 terms, so this would be a trinomial. There's no variable here. This is just a constant, so technically, this has x to the power of 0 attached to it. So this would be a constant monomial. This would be quadratic because of the 2. And it's trinomial because there are 3 terms. Last but not least, 4th degree or quartic. And it's a polynomial. Anything technically that's 4 or more is a polynomial. So next we're going to go look at adding some polynomials together. We are going to combine like terms, which means we can only combine terms with the same variable and same degree. So if I have an x squared and a y squared, they can't go together. So I'm going to do the first example with you. The other 3 examples I'm going to let you try on your own. You're going to submit those to me in Canvas. So 2x squared and x squared, those are like terms that I'm going to put together. So that would be 3x squareds. They have a positive 5x and a negative 11x. Combining those together is going to give me negative 6x. And then last but not least, I have my constant terms. Negative 4 plus 9 is going to give me a positive 5. We'll do number 2 together as well. Why not? So first I have my squared terms. 5x squared and negative 2x squared is going to leave me with 3x squared. I have 6x and negative 10x. Combining those together is going to give me negative 4x. And then my constants are going to combine together to make negative 7. So subtracting is similar. Still going to combine like terms. But before I can combine like terms, I have to distribute the negative 1 to the second set of parentheses. So here, this negative is going to go to all three of these. So I'll have x squared plus 5x minus 4. And then this second set of parentheses is going to get the negative distributed. So I'll have negative 2x squared plus 11x minus 9. And my computer will unfreeze itself in just a moment. Now that I've distributed the negative, I can go ahead and combine my like terms. So that'll give me negative x squared plus 16x minus 13 for the constant because I have negative 4 and negative 9. Looking at the second one, we're going to do the exact same thing. I'm going to distribute the negative to everybody. The first one stays the same. Distributing this gives me positive 2x squared plus 10x plus 3. Now I can combine my like terms. So I'll have 7x squared plus 16x and then minus 1 from my constants. This should start to look super familiar. Where is it in my screen? There we go. Especially if you had me for Math 1. You know I love a good box method multiplication. After we have multiplied, we're going to combine like terms and then rewrite. So since this is a monomial to a polynomial, they already have our box drawn for us. If you prefer to have your box vertical, that's totally fine. 3x is going to go on this side because that's my one term. I'll have 2x squared, 4x, and negative 5 across the top. And now I'm going to multiply. So 3x times 2x squared, multiplying coefficients gives me 6. X times x squared is going to give me x cubed. This is where my exponent is changing because I'm doing x by x squared. So technically the area of this box is what we're representing by 6x cubed. Here, multiplying coefficients is going to give me 12. Multiplying x's is going to give me x squared. And finally, I'll have negative 15x. So my final answer here would be 6x cubed plus 12x squared minus 15x. Let's go ahead and let's check out number 4. That one's a little bit more massive. So I'll have 2x to the 4th on the side, and then 2x cubed, negative 3x squared, negative 5x, and 7. So multiplying coefficients here is going to give me 4. X cubed and x to the 4th, remember we're adding our exponents. So that'll give me 7. Here, coefficients is going to give me negative 6. Exponents is going to give me positive 6. Coefficient for my next box would be negative 10. Exponent is going to be 5. And then last but not least, we'll have 14x to the 4th. So this would be 4x to the 7th minus 6x to the 6th minus 10x to the 5th plus 14x to the 4th. And that would be my final answer. Very similar if we bump it up to a polynomial times a polynomial. We're still going to use the box method. And we're going to combine like terms inside of the box and rewrite. It does not matter if it's a binomial times a binomial. It doesn't matter what you put on the top and what you put across the side. So multiplying outside in, just like we did on the last one. This is going to give me 8x squared, 6x, negative 20x, and negative 15. Now in this case, I do have like terms. The 6x and the negative 20x can combine. So I'll have 8x squared minus 14x minus 15. We'll do number 2 as well. So this would be 3x squared, negative 5x, negative 9x, and positive 15. My like terms here on the corners. So I'll have 3x squared minus 14x plus 15. Bumping it up to a binomial times a polynomial is no different. We're just making the box bigger, so I'm still going to use the box method, and I'm still going to combine like terms. We're just going to have more that's going on inside. So coefficients here is going to give me 6, and I'll have an exponent of 3. Here I'm going to have a coefficient of 9. The exponent will stay the same because there's no x. Here I'll have 8x squared and 12x and 10x and 15. So now that I've represented the area of each of these smaller boxes, I'm going to combine like terms. So I'm going to combine the x squareds and I'm going to combine the x's. So I'll have 6x cubed plus 17x squared plus 22x plus 15. I'm going to leave the other two for you. And last but not least, we have some word problems here. We're going to talk about the process for each question. I'm going to let you carry out the process on your own and submit your answers to me in Canvas. So if we're putting new carpet in her living room is a rectangle. We have the length and the width, and we need to find the amount of carpet that she would need. Well, that's going to be an area problem. So what we're doing here is length times width. So I'm going to end up doing the box method with the length and the width. For number 2, talking about a fish tank and how much water it could hold. This is a volume question. So I need to do length times width times height. Personally, I would do 3 times m minus 4 first. I would figure out what that gets me, and then I would multiply that by 2m minus 5. So you're actually going to have to multiply twice in this case. And finally, we're building a fence around a square yard. Since it's going around the whole yard, this is perimeter. So all of these sides are 3n plus 6. So you could add them up together 4 times, or you could multiply this by 4 since it is a square. And either one of those methods will get you to the same answer.